Hello all and welcome back. So in this video, let us now continue our discussion on graphs and now let's learn about few important terminologies which will be used in graph. Now just like these terminologies will be helpful in understanding graph, solving its question as well as when we will write the code. Okay, so many terminologies in tree were helpful. So graph being the same kind of structure, here also we have some different terminologies which we will be using. Okay. Great. So the very first one is the node or a vertex. A vertex or a node represent an individual element in a graph. Okay, so let me write it down as well. Individual element in a graph. So it is known as a node or a vertex. Multiple are known as nodes or vertices in a graph. To understand it very easily, let's say we are taking a map, then a city. Okay, that's a vertex. If we are talking about social network, then a person can be overall represented by a node or a vertex. So all these points, now if I draw the graph, this is one vertex, right? So there can be multiple vertex or node in my graph. Great. Next one is edge. Edge again, I think we have discussed already. Edge is a connection between two vertices, right? So it is a connection between two vertices. For example, if let's say I join, this is vertex A and this is B. If I join them, so this is an edge. In case of a city map, again, this is just like a road. So two cities are there, they are connected by road. Airport are connected by a path, a airfly path. Train stations, they are connected by the railway tracks. So that is what an edge is. Now this edge can be either unidirectional or bidirectional, right? So it can be unidirectional or bidirectional. So let me help you to visualize this a way lot better, though I'm pretty sure it will be clear. Unidirectional is something like, let's say, follow in your social networking, right? So it can happen that you are following someone, but that person is not following you. Whereas in a overall roadmap, the roads, you can go from one city to another and also vice versa. That is from A to B you can go and from B to A also you can come. So it's a bi-directional edge, right? So let us see this in a lot better visualization, everyone. Again, I have found a very awesome website for you all to understand this. Let's say this is one node, this is another node. Now they are joined. Okay, let me just take, yeah. Now if this is directed, so right now you can just go from 1 to 2. If I join this as well, now you can go from 2 to 1 as well. Okay, so this is overall a bi-directional edge. Node number 1, node number 2. Great. So let us now see about the adjacent vertices. And again, these are very important to understand. Don't try to just remember or I would say rote learn it. Try to understand from where this definition are coming. Okay. So two vertices are said to be adjacent if they are connected by an edge. If connected by an edge. Right. So for example, two cities which are directly connected to each other, they are in adjacent vertex, adjacent node, right? A and B in this example are adjacent vertices. Okay. Let's say if I name this C and if I name this D, because C and D, they are not directly connected to each other or anything, they are not adjacent vertices, right? In a real terms, if you are friend with someone on Facebook, your profile and the person you are friend with, you are a adjacent vertex in terms of graph. Okay. Great. So let us make C a adjacent vertex of A as well. So this is how it will look like. As of now, we are taking, let's say, bidirection. Okay. Great. Now let us see about degree, everyone. So degree is the of a vertex. Okay, it is defined for a vertex. Is the number of edges connected to it. So number of edges connected to a node or vertex. I think it should be pretty easy to understand. If I just mention degree in green, then you can see that A is having a degree of 2, B as 1, C as 1, and D as 0. Okay, so in a very easy term, degree is just how many edges are connected to my particular uh, node. Now, in terms of a directed graph, we can have a in degree and an out degree. So let me mention that as well. Let us mention that in this color. So in degree versus out degree. Again, pretty easy to understand. If I just, let's say, if I just draw a edge from A to D to A, and it is just in one direction, right? So here A is not pointing to, and let me draw it in red so that it is easy to follow everyone, so that you remember that and able to join the color. See, now this is a directed edge. D is connected to A. Okay, from D you can go to A, but the other way is not possible. So A now has an in degree of 3, but out degree of 2, right? So I can write it down as well. For A, in degree is 3, out degree is 2. Because things which are coming towards A, that is 3 in number. But from A, you can just go to 2. Okay. Again, we can understand this in terms of followers as well in Instagram. So if you have, let's say, followers as 500, then that is your in degree. But if you are following 1,000, uh, like let's say profile on Instagram, that is your out degree. Because from your profile, you can reach out to their profile. So from Instagram or these relatable example, pretty sure that it will be a lot clear. Okay, great everyone. So let us now move forward and discuss about path. Now, path in terms of definition is known as a node. Okay, let's say if from a node U to a node V. Okay, or let's say from A to B. If you are able to go from a one node to another node via sequence of n plus one node, right? So let me make it a little easy. For example, here from C to D, C to B, we can go, right? We can start from C, we can go to A, then we can go to B. So it's a path, right? From one node, you can go to another node via, let's say, sequence of n plus 1 nodes, right? So if you want to go from C to B, we will have to go from 3 nodes. Now, we can just write the definition as well. Let me write it as well. A path, let me just maybe write it here. A path of length n from a node, let's say U, to a node, say V, is defined as sequence of n plus 1, okay, nodes, such that we say that P is equals to U naught, let's say U1 dot 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 all the way to UN. Okay, so let's say if I have multiple nodes, so from we can maybe take it as U1 to UN. That will be better, right? So from one node to another node, you can go via these nodes. So for example, from C to B, the path is CAB, right? Now it is actually cyclic, okay, or path is said to be closed if this V naught is equals to Vn. So if here would have been another overall edge, then this path would have been closed path, right everyone? As of now, it is open path, but now it is a closed path. Great. So I hope this is clear as well. Now let us talk about the last one, which is a cycle. A cycle in a graph is a path that starts and ends at the same vertex. So the same thing which I am saying, that is actually known as cycle. If a path start and end at the same vertex. What does that mean in terms of definition? So the reason I asked, I basically have written down the definition. It's same only, that if nu naught equal to nu n. So let's say from C to B, we are making a path from C to C. Let's say it is going to be C A B C, right? So this is a path and it's a cyclic or a closed path. We can see the same in the visualization as well. So let's say if I'm just drawing another node, we can keep it here. Now this overall path, it's a cycle, something which we cannot have in a tree. And it's a closed path as well, right? We can see that it is getting closed. Now if you are starting from 2, if I have to write in terms of path definition, how can I write this? Pay attention. I can say it's a path like this: 2, 3, 1 and 2, right? So it's a closed and a cyclic path. We start from 2, we are ending at 2 again. We can draw it like this. Hence, it's a closed or a cyclic path. Great, everyone. So I hope all these basics are clear. Just a little bit space constraint, but I made sure that all the definitions are there so that you can revise it. And also, in case of any exam, it is a lot handy. Using visualization and the relative example, I am pretty sure that it must be a lot clear. Okay. So please make sure that these overall 6 are the major one. Other can also be there, but these are the one which are commonly used. Now you can define or come up with any other terminology as well, right? But these are the one which is more than enough. Going forward in the next video, we are going to discuss the types of graphs. So different types of graph. One thing more I would like to mention, in graph, I will be taking things a little slow. The reason for that is I have seen that when students start with graph, they are so exhausted with so many data structures and question that here they don't have the energy to understand it if it is if it is just covered quickly. So I want to make sure that each and everything you are able to understand and then do the question, because if you understand things properly, questions are going to be a lot easy. So I want to make sure that with proper visualization, okay, not just by drawing here, I am making sure that I'm showing you that on that visualization tool as well, right? So please make sure that you don't get confused in this. And in the next video, let's talk about different types of graph.